All right, let's look at the homework 15.5, problem number 6. All right, so let's find this these following moments of inertia. All right, so let's work on I sub x. So it's a moment of inertia about the x-axis. Right? To find that, all we have to do is we just need to evaluate the double integral over this region, the quarter disk. I'm going to just call it D, right? Then we have a y squared times the density, so I'm going to call it the rho of x comma y, and then area element, right? And in this case, a rho is going to be, it says that the density at any point is proportional to the square of its distance. So we know that here, rho is proportional to, so which means that k times, right, square of the distance from the origin. So it's going to be x squared plus y squared, right? We have that. All right, then I'm going to convert this in polar coordinates. So this is going to be equal to, right, double integral, right? So actually, I'm going to use a blue, right? So we have a double integral, right? So y squared in polar coordinate would be r squared sine squared of theta, right? And then here, it's a k times x squared plus y squared would be r squared. So this is going to be k times r squared, right? And then area element in polar coordinate would be r dr d theta, right? So this is a quarter circle with radius 6 because r squared is 36. So r is going to go from 0 to 6, right? And then the angle theta is going to start from 0. Then it's only in the first quadrant, so it's going to go up to pi over 2. All right? So let's clean this up a little bit. So this is going to be, right, so I'm going to combine all the ones with r. Right, first, the k is just a number, so I'm going to kick k out. Right, then you have an integral from 0 to 6, right? Then collect all the r's, r squared, and another r. So it's going to be r to the 5th power with respect to r. Then multiply by integral from 0 to pi over 2. And what's left would be only sine squared of theta and d theta. Right? So we have that. All right, so why don't we pull up GeoGebra to see if we can compute this value here. All right, so I'm going to pull up GeoGebra. All right, so we're going to do, I'm going to just do the one integral at a time. So you have an integral. All right, so integral of, so function would be, I'm going to do the first one. So it's going to be r to the 5th, right? And variable is r, and going from 0 to 6, and hit enter. So we have a value. And second integral would be, right, so I'm going to do an integral, right? Function is actually just sine squared of theta. Right, so that's that. And theta is going to go from 0 to pi. All right, it came back and looks like we got the I sub x correctly, right? But you can see that this object is x and y are interchangeable. So I sub y is going to be exactly the same value. So I'm going to just say 1944 k pi, right? Then let's check that. So submit for testing. All right, I came back. It looks like we got I sub y correctly. All right, I sub z or I sub 0. So this is a moment of inertia about the origin or the z-axis. Is going to be the sum of I sub x and I sub y. So we're just going to add them up. So what you get is going to be, let's say 4 plus 4 is 8. 4 plus 4 is 8. And 9 plus 9 is 18, and 1 plus 1 is 2, so it's going to be 3088 K pi. Alright, so let's check the answer. Submit for testing. Alright, I came back and looks like we got all three moments of inertia correctly. Alright, that's it. I hope that this was clear.